This is the lesson of chemistry study for anyone of the MIT in Boston that has been guest of the IIS Istituto of Cremona. I ask to appreciate the spontaneity, but also to forgive the errors. I have to thank my students for the appointments, Annie for her competence. I am also have always been behind the television
Hello
camera.
Annie.
Ciao.
How are you? Ciao, come va?
Va bene.
Ti trovi bene qui nella nostra scuola?
Sì.
Ti piace fare chimica con noi?
Sì.
Sì. What is the theory of Bronsted and Lowry
So Bronsted
and Lewis?
okay. So Bronsted and Lowry were two scientists in 1923 who published separate papers. Bronsted was Danish and Lowry was English. They decided that they needed a more complete definition of acids and bases.
Bene.
Okay?
Allora potete fare
Okay. What is the ionic dissociation of acids and bases?
I didn't give the full definition of Bronsted and Lowry.
No.
What is the ionic dissociation of acids and bases?
So when an acid or a base is put into a solution, it ionizes. Okay? So Lewis said that Lewis's definition of acids and bases states that an acid accepts an electron pair, whereas a base donates an electron pair. When an acid or base becomes ionically dissociated, there will be an increase or a decrease of hydrogen ion concentration. Okay? So, an acid will increase the concentration of hydrogen ions, whereas a base will decrease the hydrogen ion concentration because it's accepting those hydrogen ions. ¿Hai capito? Bene. Electrolytes is any substance that contains free ions, and it will make this substance electrically conductive.
Okay.
Avete capito?
Yes.
Okay.
Can you give an example?
An example of an electrolyte is when you take table salt, sodium chloride, which is NaCl, and you add it to water. The salt will disassociate in the water and create positive and negative ions. The sodium will become positively charged, Na+, and the chloride will become negatively charged, Cl-.
What are the acids and bases?
The acids and bases are defined to be, good question. So in the 17th century, there was a scientist by the name of Robert Boyle in Ireland, and he first decided to characterize the properties of acids and bases such that acids taste sour, they are corrosive to metals, they change litmus paper, acids, and bases. So acids taste sour, they're corrosive to metal, they change litmus paper from red to blue. Yes.
And when were they found?
Well, bases, I'm telling you now. Robert Boyle discovered them, or well, characterized them and defined them in the 17th century, which is about the 1600s, a long, long time ago. And bases, on the other hand, with respect to acids, they taste bitter, they feel slippery, and they change litmus paper from red to blue. Okay?
Okay.
More generally, we'll talk about that later.
Who first studied the reaction of neutralization acids and hydrogens?
So, Arrhenius was was a Swedish scientist in the 1800s, and he defined acids and bases such that if you were to mix an acid and a base together, it would create salt and water. The acid is defined to donate hydrogen ions, H+, and bases are defined to give hydroxide ions, OH-. When you add an acid and a base together, typically you will get a salt and water, because the hydrogen ions plus the hydroxide ions create water, aqua.
Yes.
Brava.
So the theory of Arrhenius has some limits.
See, Arrhenius defined basic acid and base properties. However, it doesn't fully explain why some materials, such as common baking soda, which has an empirical formula of sodium, hydrogen, carbon, oxygen 3, or NaHCO3, it has these basic properties. However, it has no hydroxide ions when it is dissociated in water. Avete capito?
Yes.
Yes.
Bravi!
Sì, ma non si può fare anche il barbarino non esiste, guarda.
-1 via.
And can you tell us something about the mathematical concept of pH?
See, but first we need a blackboard, so we will be moving this way. Okay. In 1909, a Danish biochemist by the name of Søren Peter Lauritz Sørensen invented a pH scale. pH can range from 0 to 14, with 7 being defined as neutral. pH mathematically is written and defined to be the negative log base 10 of hydrogen ion concentration. Okay?
Okay.
So, POH, in contrast, is the negative log base 10 of the OH minus. Okay? So, the dissociation constant of the following formula and following reaction is 2H2O, 3O plus, OH minus. Do you understand this reaction?
Yeah.
Okay, good. So the dissociation constant of this formula is the concentration of this ion times the concentration of this ion divided by aqua squared. Okay? Okay. So, can anyone tell me what the pH will tell us if it is less than 7? What is the solution?
Easy.
It's acidic. Bravo. And if it's greater than 7?
Base.
Bravo. Okay, so we can do some examples with this. A neat little trick is that pH plus POH of water should add up to 7, because the pH of water, which is neutral, is always 7. Okay? So let's do an example. Ooh. Okay. So we have a solution such that it is a 0.01 molar solution of hydrochloric acid, and we need to calculate the pH. So 0.01 moles of hydrochloric acid in water. Okay? So When this dissociates in water, what is the concentration of hydrogen ions?
H plus.
10 alla meno 2.
Two. See, so if this is the if this is the concentration, what is the pH?
But why is so?
10 to the minus 2? Because hydrogen chloride will dissociate completely in water and create H plus Cl minus. And because we have 0.01 moles of this, after the reaction, we still have 0.01 moles of this and this. Okay? Okay, good question. So, we have 10 to the minus 2 molarity of hydrogen ions. The pH, does anyone remember the definition?
Log base 10.
Algoritmo.
H plus.
Bravi. Okay. So, negative log base 10 of 10 to the minus 2 is equal to 2. See. So, is hydrochloric acid acidic or basic?
Acidic.
Bravi. Very good.
Ma perché c'è una voce fuori campo? Non mi piace.